This is the rest of the notes for Algebra 2, Unit 4, Lesson 11, Solving Exponential Equations Using Logarithms. Okay, so now that we have seen the method of solving an exponential equation using logs, we can look at some problems using exponential models that we learned previously to do this. So let's take a look. So let's look at a percent increase problem. If quantity Q is known to increase by a fixed percentage P in decimal form, then Q can be modeled as Q of T equals Q0 times 1 plus P to the T. All right, now this is, remember, the percent increase. It's 100% plus the percent increase as a decimal. Remember doing that back in Algebra 1? Okay, and then Q0 is the amount of Q at T equals 0. So that's the starting value. And T represents the time. So let's take a look at this using the exponential models to solve the equation. Let me move it down a little bit here. A biologist is modeling the population of bats on a tropical island. When he first starts observing them, there are 104 bats. The biologist believes that the bat population is growing at a rate of 3% per year. So if we know that, write an equation for the number of bats, B of T, as a function of the number of years T since biologists started observing them. All right, so we need to know our starting value, which in this case is going to be 104. All right, now if you're increasing by 3% a year, overall you had 100% plus the 3%, so that's going to be 103% increase overall. As a decimal is 1.03, so that goes here, 1.03 raised to the T. So that's our equation. So using the equation from part A, algebraic determine the number of years it will take for the bat population to reach 200. Round your answer to the nearest year. So this is not going to come out nice and even. We're going to figure out what T is without having to solve this, or without having to use our table. So what we do is we want to reach 200, so that's going to be B of T. So my equation is going to, I'm just put it over here, 104 times 1.03 to the T, we want that to equal 200. Now normally what we do is we put this in the calculator and go to the table and figure it out, but we're actually going to algebraically solve this. All right, so our goal here, first of all, is to get the exponent by itself. So we have to move this 104. So we divide by 104 here, divide by 104 here. Okay, now if I go to my calculator, I get 200 divided by 104 is 1. I'm not going to use that, so I'm going to hit math, enter, enter, and make it a fraction. 25 over 13. So going back here, 1.03 raised to the T is equal to 25 over 13. You can actually just leave it as 200 over 104 if you want to. Okay, so now I need to know what the exponent is. So what I'm going to do is I need to find an exponent. I got to take a log. So I'm going to do the log of both sides. Which you do to one side, you got to do the other. Doesn't matter if you're doing a log or any other equation. On the equation, you have to do that. Okay, so take the log of both sides. All right, now, since we're doing a log now, this is an exponent. Where does an exponent go in the log? It goes out in front. So this is T times the log of 1.03 is equal to the log of 25 over 13. Okay, now I need to solve this for T. Well, I have to get this log of 1.03 off of there. So I just divide by log of 1.03. Okay, so that gives me T equals, I'm just going to write it down what it is, log of 25 over 13 divided by the log of 1.03. Now notice I didn't do this a piece at a time. I'm going to put this whole thing either in my calculator or Desmos, and I'll show you both ways. All right, so let's go to the calculator. All right, now overall, the log of this overall is a fraction. So I'm going to use my fraction key just to save myself a little time. You don't have to, you can just do divided by. All right, so there's your fraction. So we have the log, use the log key right here, 25 divided by 13. You can use the fraction key also there if you want to, but I'm just going to do it this way. Divided by the log of 1.03. Log 1.03. Close your parentheses. All right, so this is approximately 22.122. So it said approximately to the nearest year is going to be approximately 22 years. So T is going to be approximately 22 years. Because this equals 22.12 dot dot dot. Okay, so about 22 years. All right, now if you're using Desmos to do this, let me go to Desmos here. There's Desmos. Okay, now when you go to the calculator here and you want to enter a log, notice there's no log key on this screen, but if you go over here to functions, you can have trig, stats, distance, and distributions, and miscellaneous. Under miscellaneous is the log function. So if you type this in, it's going to be log 25 divided by 13. All right, now notice this automatically makes into a fraction. Close your parentheses, forward arrow, close your parentheses, divided by the log of 1.03. Function key, now it stayed on the log, that's the last one we use, log 1.03. And then close your parentheses, and notice here, there's your answer, 22.12. That's the same answer that we got on the graphing calculator. See, there it is, same answer. Okay, so you can use either value, or either calculator or the Desmos function to do that. Okay, now that we've done an exponential growth, let's do an exponential decay. We have a stock has been declining in price at a steady pace of 5% per week. If the stock started at a price of $22.50 per share, determine algebraically, which means don't go to your calculator table, the number of weeks it will take for the price to reach $10. Round your answer to the nearest week. Okay, so same idea when you start with this. So I'm going to say $22.50 is my starting amount. Now, if I am decreasing by 5% each week, what percent is left over? Well, remember, if you're 100% and you minus 5%, what's left over is a 95% of what you started with. So we're going to use 0.95 as our multiplier, raised to the however many weeks. I'll just use X for the number of weeks. How many weeks it will take for the price to reach $10. So we want this to equal 10. Okay, so let's solve this for the, get the exponent by itself. So we want to divide by 2250. Okay, so let me grab my calculator. 10 divided by 2250 divided by 22.5 is 0.444. I'm not going to use I'm not going to round it off. I'm going to hit a fraction. Math, enter, enter. Is 4/9. Okay, so I flip back here. So 0.95 to the x is equal to 4/9. Okay, now I've got the exponent by itself. I want to do a log of both sides. Log of 0.95 to the x is equal to 4/9. Oh, log of 4/9, sorry, forgot the log part. Log of 4/9. All right, let's go up here. All right, now applying the rules for logs, if this is an exponent, it's got to go out front. X times the log of 0.95 equals the log of 4/9. Okay, divide by log 0.95. All right, and that's what we want to put in our calculator. So x is going to equal log of 4/9 divided by log of 0.95. Let me grab my calculator. All right, so it's I'll use my alpha key just to make my life easy. Alpha y equals, oops, that's a stat plot, alpha y equals, there we go. Number 1, we have the log of 4/9 divided by the log of 0.95. Okay, and there we go. All right, now be very careful when you enter your logs. If you do this without using the fraction key, just make sure you close your parentheses when you do this. Log of 4/9 divided by the log of 0.95. There we go. So make sure you close your parentheses here. It's going to screw your answer up. Okay, so we ended up with about 15 to the nearest 8. So this is 15.8 909, sorry, 809 something. So this is approximately, rounded to the nearest number of weeks, 16 weeks. So there we go. We just figured that out. Okay, for our final discussion, we return to valuing logarithms using our calculator. Many modern calculators can find logarithm of any base. Some still only have common log base 10, others we'll still see. Ours actually have the log base, so we can still do the exponents, but find the solution to each of the following exponential equations in terms of a logarithm with the same base as the exponential equation. Okay, so basically what they want us to use the log using base 2 instead of log base 10. So let's get the exponent by itself, just like we normally do. Add the 3. So we get 4 times 2 to the x is equal to 20. Divide by 4. And we get 2 to the x is equal to 5. Okay, now instead of what I would probably do is I just do the log of both sides. All right, but they want us to use the same base. So they instead of using the log of 10, we're going to be using the log of 2. So log to the base 2 of 2 to the x. Oops, 2 to the x. Sorry, I forgot the x. Is equal to log to the base 2 of 5. All right, now the interesting thing here, if I have log to the base 2, let me put the x on the outside. Let's make it do it that way. Okay, log of base 2 to the x. Let's do it like that. All right, what is log to the base 2 of 2? 2 to what power is 2? Well, isn't that just 1? So this is going to be just going to be x is equal to, because this is actually x to the log base of 2. Sorry. X log to the base 2 of 2 is equal to log to the base 2 of 5. And we just said log to the base 2 of 2 is equal to 1. So this is going to be x is equal to log to the base 2 of 5. So if you wanted to calculate that, you would just put log to the base 2 of 5 in your calculator and you've got it. You can do it that way as well. Now, I probably would just done the log base 10. It would be log of 2 divided by log of 5 divided by the log of 2. All right, and you can do it either way and you'll get the same answer. Okay, now let's do the last one here. First thing we would have to do is divide by 17. All right, I know 4/17 doesn't reduce to a nice fraction, so I'm going to leave it like that. 5 to the x to the third, x over 3, I'm sorry. 5 to the x over 3 is equal to 4/17. So I'm going to leave it as 4/17. All right, now since my base here is 5, I'm going to use log to the base 5. To the x over 3 is equal to log to the base 5 of 4/17. Okay, remember the exponent goes out front. It's x over 3. Log to the base 5 of 5 is equal to log to the base 5 of 4/17. Okay. All right, remember log to the base 5 of 5, 5 to what power is 5 is just going to be 1. So this is actually going to be x over 3 times 1, which is x over 3, is equal to log to the base 5 of 4/17. And then to solve for x, we would have to multiply both sides by 3, right? So we would say x over 3, multiply this side by 3, is equal to 3 times log to the base 5 of 4/17. There we go. So this is going to be x is equal to 3 log to the base 5 of 4/17. All right, so you can do this in terms of this log of the same base. 95% of the time you'll be using the base of 10, so don't worry about this, but this is just to show you there's other ways to do this. Okay, so that's it. We're going to be talking about the homework in a little while.